Say hi to the class.
Hi.
All right. Well, as you can see, I'm out today. So I figured I'd put together a little video for you to give you some instruction on our Chapter 3 Inequalities. So even when I'm not in class, I guess I can still bother you guys and not give you a free day. But anyway, what we're going to look at here in Chapter 3 are inequalities. So for the most part, I believe you guys have been introduced to inequalities. There's not a whole bunch new here for this section. We're going to do 3 sections today. 3-1, 3-2, 3-3. Actually, I think we're going to do 3-4 as well. So between today and tomorrow, we're going to cover those 4 sections. So here's our notes for these sections. And you guys can take the notes. I'll post them on the e-board. I'll go through, I'll show them on the video, but they'll also be posted on the e-board if I'm moving too quickly for you. All right, so as we get started here, as I said, we're solving inequalities. And what is an inequality? Simply put, just a math sentence that compares two expressions using the symbols greater than, less than, greater than or equal to, or less than or equal to. A solution of an inequality is just any number that makes the inequality true. So inequalities have infinitely many solutions typically, okay? But you show them by writing something like x is greater than 5. That would be showing what numbers are greater than or equal to 5. And we can show that solution through a graph as well. So if x can be greater than, I'm sorry, not equal to, but just greater than 5, we can draw our graph. We put 5 in the middle, make sure our number line's correct, and we have our open circle, which we'll talk about in a second, and showing all the solutions that are greater than 5. Okay? Another example is sometimes we get confused when the variable's on the right-hand side. So if you have -2 is greater than or equal to x. Think about that. What can x be? -2 is greater than or equal to x. If that confuses you and you're trying to figure out what x is, you can flip the whole inequality. So notice, not only do I switch the x and -2, but I flip the inequality symbol as well. So instead of saying -2 is greater than or equal to x, I can say x is less than or equal to -2, and in my opinion, is much easier to understand. So I can do my graph. Notice I put -2 in the middle. This time I close the circle, and I'm showing all values that are less than -2. Okay? So yes, you can, if that gets you confused and you're trying to read this, we can flip them around. Just make sure you flip the inequality symbol. And what I kind of tell myself is it's closed towards x, so it's closed towards x. It's open towards -2, so it's open towards -2. That tells me that I did that properly. Okay? All right. Moving on. Okay, so when graphing solutions to inequalities, sometimes you use a closed circle and sometimes it is an open circle. And again, this stuff has been told to you guys last year, but if the inequality that you're using is just a less than or greater than, notice we're not including 3, we're not including 6, so it's open circles going in the appropriate direction. When we use a less than or equal to or a greater than or equal to, now we close the circle and we go in the appropriate direction because we're including that as an answer. 50 is an answer here. 50 is less than or equal to 50, so we include 50. Whereas here, 3 is not less than 3, so it's open. Some students ask, well, why don't we just start at 2? Don't forget, you have all the other numbers in between 2 and 3 that satisfy that, like 2.9, 2.7, and things like that, okay? So when an inequality is just greater than or less than, we use the open circle, we're excluding the value, and when the inequality is greater than or equal to or less than or equal to, we use a closed circle, so we include those values. All right, how we doing over there? Everybody paying attention? Nobody in the back's talking over there? All right, so that's pretty much 3-1, and then we go into solving inequalities. And really, guys, if you remember, solving inequalities is the same exact thing as solving equations. So that whole chapter that we just did on solving equations is what we're going to use here for solving inequalities, with one rule to remember. And I'm sure you remember what that rule is, okay, which we're going to get to in a second. But as long as you follow that one rule, the same rules apply for that we just used for equation solving. Okay, so we follow the same rules that we use for solving equations. We distribute and collect like terms. We get rid of any denominators if we want to do all that stuff like we were doing before. Then we add or subtract to get all variable terms on one side and all the constant terms on the other, especially if there's variables on both sides. And then we're going to multiply or divide to make the variable coefficients equal to 1. And bam, there's where the rule comes in. Remember, however, whenever you multiply or divide both sides of the equation by a negative value, the inequality sign reverses. Only when you multiply or divide by a negative, not adding, subtracting. That doesn't change it, okay? Just multiplication, division. When I come back on Wednesday, I'll show you why. I'll demonstrate why that's the case. But today, just remember that rule. If you multiply or divide by a negative, flip the sign, okay? We flip the inequality sign. And that's only if you multiply or divide both sides of the equation, not if you're distributing, okay? That wouldn't change the sign. So here's a couple of examples. So we have 5x minus 30 is less than or equal to negative 15. So I would add 30, follow my rules. So I'm adding 30, nothing changes. I divide both sides by 5, bam. I didn't divide by a negative. I just divided by 5. There's my solution is x is less than or equal to 3, and I graph that. Another example. So we have 2/3 x plus 8 is less than 10. So it's a two-step inequality. I'm going to subtract 8 from both sides, and then I'm going to multiply both sides by the reciprocal of negative 2/3, which is negative 3/2. Now in this case, I multiplied by a negative value. My inequality sign, which started as a less than, now becomes a greater than. X is greater than negative 3. Okay, and I would go ahead and graph that solution. All right, and again, you can see there in green, since you multiply both sides by a negative, the inequality sign reverses. All right, that little be careful down there, let's see what that says. Be careful, you only switch the inequality sign if you are multiplying or dividing both sides by a negative value. Okay, where you don't want to make the mistake of switching the sign is something like this example where you distribute negative 2 here into this side, okay, and then we're going to go ahead and combine like terms. Just because I'm distributing negative 2 in, I wouldn't flip the sign. Only it's when I'm trying to make the coefficient 1. So then I combine like terms here. I get negative 5t minus 4 is greater than or equal to 1. Add 4 to both sides. Negative 5t is greater than or equal to 5. Then I divide by negative 5. Bam, flips. So t becomes less than or equal to negative 1. And you can pick any value that's less than or equal to negative 1, plug it into the original problem, and it should hold this one true. That's what makes it a solution. Okay? And there's the graph right there of t is less than or equal to negative 1. And of course, to make it one step a little bit harder, we do have special case inequalities. All right? If you remember what the special cases were for equations, it's just when all the variable terms canceled out and you were left with either a true statement or a false statement. Well, guess what? The same thing's going to happen. There's two special cases. Every number works, and no matter what you plug in, it's going to be true. And you're going to see that in this case, you have 10 minus 8a is greater than or equal to. And then if I distribute over here, I basically have the same thing on both sides, just like we did before. I'm left with 10 is greater than or equal to 10, which is true, because 10 does equal 10. Since it's a true statement, no matter what you plug in, both sides are going to be equal to each other, okay? So therefore, you would write solution is all real numbers. Then the other special case is if all the variable terms cancel out, and now you're left with a false statement, okay? Like negative 5 is greater than 7. In that case, negative 5 is not greater than 7, so therefore, there will be no solutions to this inequality. So just like we did before, you look and see, if the statement is left is true, that means everything's going to work. If the statement that remains is false, nothing will work. And really, guys, that puts you through, that's it. That puts you through 3.1 through 3.4. So for today, as you guys move forward, I just put together an assignment for you to do. It seems like it's going to be a lot of work when I show it to you, but quite frankly, you're just writing equations for the first part of it and then solving simple two-step and one-step equations for parts of it, and then you build yourself up into the multi-step. So do what you can do. Make it neat, put it on paper, and I will collect what you have done at the end of the period today, and then we'll go forward from there, okay? And what else? Don't forget to turn in your activity list. That is due today, so that needs to be turned in. I did not get to your test yet. I'll get to them. They're still at school, so I'm not going to get to them today. I'll try to get to them tomorrow during the day and get them back to you for Wednesday, for Thursday. All right. Stay good. Listen to Miss Allison Drini, and see you guys in a day.